The examples of substitution that we were doing had all the problems already solved for y. You had one of the examples where it was already y is equal to something. So what we're going to do today is we're going to look at examples of substitution where, sorry, I just need to do something really quick. We're going to look at some examples of substitution problems where one of the equations is not already solved for y. So you have to do a little bit of mathematical jiggering to get everything how you want it to be. So the example I'm going to show you right now is, let's say that we have x plus 2y is equal to 16. And then our second equation that we're going to use here is going to be, let's say, 3x minus 5y is equal to negative 29. So this is similar to what we were doing yesterday. However, it's up just like half a notch from what we were doing yesterday. So this requires just a tiny bit of mathematical jiggering. And here's where the mathematical jiggering comes from. Neither of these already have an equation that is already solved for either x or y. So here's how you handle it. Step number one, you look for a coefficient, and that's a big mathematical word that I've used before, coefficient of 1. Do you guys remember what that word coefficient means? I've used it at least once in this class already.
The number that multiplies the variable, yeah.
Okay, cool, absolutely. The number that multiplies the variable. In even simpler terms, because Tyler hit it right on the head. He was absolutely right. In even simpler terms, it's the number that goes in front of the variable. Okay? So here, I've got x, 2y, 3x, and minus 5y. You always want to make sure that you're taking the symbol that's in front. So like this isn't 5y, this is minus 5y. You always want to make sure that you're taking the plus or minus into account when you're looking at what the coefficient is. Like this is positive 2y. This is minus 5y. You always want to make sure that you're taking whether it's positive or negative into account. So you're looking for a coefficient of 1. So which of these four variables that I have here, which of them has a coefficient of 1? Right, this one right here. So there it is. Exclamation point, exclamation point. I'm going to underline it right there. So I want to focus on that one. Okay? Now, not too terribly long ago, I think it was maybe 8 weeks ago, we did a lesson where I showed you guys how to get a specific variable alone. Okay, you can react as strongly to it as you want to. It happened. I was here. I watched me teach it to you. So what you want to do is isolate that variable. Isolate that variable. So you want to get this plane x, or it might be a plane y. Whatever it is, you want to get this variable that has a coefficient of 1. You want to get it by itself, and that means getting rid of whatever variable is by it. So in this case, it's got a plus 2y next to it. And so I want to get plus 2y away from it. So I've got x plus 2y equal to 16. I have to get plus 2y onto the other side. How do I move plus 2y onto the other side? Not divide, no. Because, yeah, I'm going to minus it, because this is a positive 2y. I'm going to minus 2y from both sides. So minus 2y minus 2y. So on the left-hand side, 2y minus 2y goes away. Now on the right-hand side, please nobody say 14y. Please nobody say 14y. No. Thank you, Annabelle, and anybody else who said that. 16 minus 2y. Okay? The reason that this is not 14y is this is like saying I have 16 high schoolers and I subtract 2 middle schoolers from that. It doesn't become 14 middle high schoolers. It still is 16 high schoolers minus 2 middle schoolers. Like they don't suddenly become this weird amalgamation of two different things.
That'd be cool though. That's what I meant.
Apple oranges,
right.
monkey gorillas, and spider monkeys.
These two things are different, so they can't combine using addition or subtraction. On the left-hand side, I just have x now. Now, this looks just like what we were doing yesterday. Now, I can take what x is equal to, which is 16 minus 2y, and I can substitute this in for x in the other equation. So now, I can rewrite the other equation to be, instead of 3x minus 5y equal to negative 29, I can rewrite that as 3 times, in parentheses, everything that x is equal to, which in this case is 16 minus 2y, close parentheses, minus 5y equal to negative 29. Now from here, it's the same stuff we were doing yesterday. I'm going to distribute, I'm going to combine like terms, divide by the coefficient. So 3 times 16, 3 times minus 2y. 3 times 16, anybody, what's that? Awesome, thank you, 48. And 3 times minus 2y. Negative 6y, thank you. Minus 5y equal to negative 29. Now I'm going to combine my like terms over here. What are they going to add up to? Negative 11y equal to negative 29. And then I've got 48. Now I need to get 48 onto the other side. Not add it because it's already plus, so I need to subtract it, like Annabelle said. So I'm going to minus 48 from both sides. And this will cancel out. And now I've got negative 11y equal to, got negative 29 minus 48. So I have to do negative 29 minus, okay, negative 77. One more step to find y. Divide by both sides by negative 11. And y is equal to 7. Now I need to find x. And to find x, I'm going to go back here to this modified equation right there. I could go up to this original one if I wanted to, but I already have this modified one where it just says plain x is equal to, so I might as well just use this one. So x is equal to 16 minus, and instead of 2y, I'm going to do 2 times 7. So x is equal to 16 minus 14. So x is equal to 2. Now I have to write that as a coordinate. 2, 7. It's x, y. Alphabetical. X, y. Okay? Yeah, sometimes, yeah. Yeah. When you get to algebra 2, there will be problem sets that are x, y, z.
Z actually does exist.
Yeah, absolutely. When you get to higher level math, like
Where do you grab it? Where do you grab it?
it's a 3-dimensional plane.
Oh.
That makes sense now.
So like Annabelle, x and y, z comes out at you.
Yeah. Just grab it for that.
So x and y are left and right, z is forward and backward. Positive z is towards you, negative z is away from you.
I don't like this whole math thing anymore.
Okay, you don't have to like it. It still exists. If you've ever played a 3-dimensional shooter game, those use x, y, z coordinates all the time. Yeah. Yeah, that uses x, y, z coordinates. Test. Yeah, give me a minute. Well, actually, tomorrow, so the assignment I'm giving you right now, you'll have time to work on it in class tomorrow. Tomorrow we're going to have a quiz, so you'll just have to make it up when you get back. So the assignment I'm giving you guys right now. You go ahead and you have your 5 minutes up.
I'm pretty sure.
Okay, so listen please, guys. So, this assignment is coming on the heels of the one that you guys just did yesterday. You're going to have a quiz tomorrow. So, this assignment is due at the end of class tomorrow. So, you're going to have time to work on it in class tomorrow. And tomorrow we're going to have a quiz. So I'm not planning on giving you another assignment tomorrow. So you have today, you have the rest of class period today to work on it. You're going to have class period tomorrow to work on it, and then tomorrow we're going to have a quiz. And I'm not planning on giving you another assignment tomorrow. Actually, probably I can make this due on Friday if you guys promise that you'll work on it and not be pains, but yeah, I don't want you. But okay, so tomorrow I'm not going to give you another assignment, but we will have a quiz. And then on Friday we're going to talk about something called elimination. Elimination. Okay, I'll run down and make some notes. Okay, I'll be right back with more graph paper.
Wait, so is this due on Friday or Thursday? Every day.
Okay, I'll be right back.
Drink of water. I'll just have to wait forever now. What day is it? The 4th?
That's how you say it.
You bet. What? I know. I don't have anything that like can hook up to. Michael.
I got $5 wireless headphones at Target.
Michael. That's bad. Bring your night flag.
It's like
That's wrong. What is $6 for that? Come on. Well, it was 40. It's so good. It's great. They're great $60 water bottles. They're totally worth it. And it's a lot of water. Last day hydrated, man. Especially when it has a CS on it. I love your logic.
Yeah, it is.
They work so good.
On that eye,
They keep icing for like 2 days. Michael McHenry, go.
I could show you a minute.
Hey, yeah, here. No. Hey, look.
You don't have a
So what I do, I
actually.
do I need to do?
Carries mirror. I do. I have that mirror and I have a travel brush with a mirror. I carry a lot. No. No, I thought you.
What?
It just looks like you cried.
I have my eyes have been watering the past few days. Oh, see, now I
No, I
Yeah, I
have
don't
to.
work
So
out.
when I
My
play
allergies
X, I don't have that
spiked
number there.
really badly.
Holy.
Like all of a sudden I have allergies.